have been playing around with the world of asymptotes. And what I want to do is I want to go over one problem. I will tell you right now, just so you can mentally prepare for this. We're going to spend about 20 minutes on this one problem. It is harder than anything I would expect for you to do on your own in terms of a quiz or a test. Okay? I'm deliberately picking a hard problem because I will know that you really know what the heck is going on. But I also want to summarize the thing so far, because I am curious if anybody's feeling this way right now. When it comes to horizontal and vertical asymptotes, you thought you knew them pretty well, and then we started introducing all the limit stuff, and it feels like you no longer understand asymptotes. Okay? Maybe you're in the category of, I never really understood asymptotes, so it's no different now. And maybe some of you are starting to have a deeper soul kind of experience. You're like, oh my God, now I get asymptotes. I'm going to pretend lots of hands just went up. I love it. Okay, so I say horizontal asymptotes. What is everyone thinking? I say horizontal asymptotes. We're really thinking end behavior. So if I give you a function, the way that you find the horizontal asymptotes, and what I want to see is that you're going to find the limit as x approaches infinity, and we're going to find the limit as x approaches negative infinity. We're going to find both, because there's two ends. Now, if your limit as x approaches infinity, maybe it's positive infinity, maybe it's negative infinity, if what you get is 5, you find the limit as x approaches infinity, and the answer is 5. What does that mean? Juan, what does that mean? It means that you have a hole. What does it mean? You find the limit as x approaches either positive or negative infinity. Your x values are heading off to one of the infinities. The y value is approaching 5. What does it mean? Think about the graph. Alex, what does that mean?
I was thinking maybe they don't stay the same.
Okay. What do you think, Salma?
It's something restrictions.
Something restrictions. It's like we're playing Mad Libs. I'm not sure.
Like the one where the function, right, and then it has f of x, and it has a bunch of functions, and then it says blank is less than or equal to blank, which is less than or equal to.
Okay, I think, first of all, it's a Monday. And number 2, we're not 100% on board with what I'm asking here. This notation says as x approaches, let's focus on positive infinity right now, the y values are getting closer to 5. As my x values head out to infinity, what happens to the y values?
Closer to 5.
They get closer to 5. So here's like the line, y equals 5, and our notation says that's happening. That as I head off towards infinity, the y values are getting closer to 5. You know what we call that?
Asymptote.
Be specific.
Horizontal.
Right? If you see this, that means horizontal asymptote at y equals 5. Now let's make this stronger. What if this is L, right? Some number L, pi, square root of 2, 17. If the limit as x approaches infinity comes out to be L, then you know what? You've got a horizontal asymptote at y equals L. That's the conclusion I need to see written when you're doing the work. But you also need to find, well, sorry, let me back up. You might also find this is your answer. The limit as x approaches infinity of f of x is equal to positive infinity. So as those x values are heading towards infinity, what happens to the y values? They're heading towards positive infinity. Guess what your conclusion is there?
No horizontal.
There's no horizontal asymptote. In the world of your asymptote work, I need to see the conclusion, and this is the supporting work. Now, we know that we're going to check both positive and negative infinity, and it's important that we check both. Everybody okay?
Yes.
All right, thanks Juan. Okay, I'm going to switch colors so we can look at vertical asymptotes. I want to see 6 hands. How do you start this? Vertical asymptotes. How do you find vertical asymptotes? Abel.
You set the denominator equal to 0.
Okay, set the denominator equal to 0. And that guarantees you a vertical asymptote?
No.
What does that get you?
The candidates.
These are your candidates. Okay, I'm going to call my candidate C. I hope everybody's okay with that. C for candidate, not C for cookie. Okay, I'm going to take the limit as x approaches C, and I get positive infinity. Think about the graph. You have an x value of C, some number, and you get closer and closer and closer to that number. And as you get closer and closer to that number, the y values are approaching one of the infinities. Your conclusion? You have a vertical asymptote. This means, oh, Brianna, thank you so much. Vertical asymptote at x equals c. The thing I'm boxing is the conclusion. This before is the work to support it. Now, if we're approaching negative infinity, does that count as a vertical asymptote?
Yeah.
Okay, what if I'm approaching C from the left or from the right? If I get either of the infinities, my graph's heading up to infinity or down towards negative infinity. Everybody okay? But this could also happen. It's possible, and we've seen this sometimes, you take the limit as x approaches C and you don't get infinity, you get some number like, I don't know, 6.
It's a hole.
What that means is you have a hole. Okay, great. 1 person out of 20 knows that we have a hole. Good. But Janaea knew it quickly. If you get infinity as the limit, you have a... No.
Vertical.
You have a vertical asymptote. But if you get a number, then it's a hole. And so let's get rid of 6 and let's say like L, right? The coordinates for the hole are going to be C comma L. Again, this is the conclusion that I want to see. This is the supporting work. Take 1 minute while I take attendance. Make sure your notes are perfect, spot on. Check with your neighbors. Ask them any clarifying questions.
Sorry.
You get all this in a minute.
Okay.
It's not going to take so much to write this because they're already
There's a group work.
Yes, sir.
When the computer shows the white
Is it only vertical asymptotes that have cookies?
No. You'll never have a vertical. The vertical asymptote is not a hole. When you know the denominator is equal to 0, you go back and you find the limit as x approaches whatever that number is. If you get one of the infinities, vertical asymptote. If you get a number, hole. You won't get both. You'll get one or the other.
Yes, I understand.
Okay.
We'll take notes about
All right, friends, here's what I want you to do. Everybody good?
Yes.
Okay. My goal is to push your understanding with asymptotes. So I want you to take a moment and I want you to graph this example function over here on your calculator. And Josue, do your thing, son. Get me that graph. I do not expect anybody in the room knows exactly what this graph looks like. Unless you snuck in last period because you wanted to see the show twice. That's fine. That's what you want. Yeah. So it's already graphed. Yep. I mean, it's refreshing. Okay. What I care most about right now is that you are graphing this function on your calculator, If you are able to plug into the Navigator network, great. If you're able to log in, that is fabulous. If you cannot log in, it's not going to change anything at all about today. Okay. Give me a quick thumbs up when your graph matches Josue's. Okay. Looking at the graph, do we have a horizontal asymptote?
Yes.
Do we have evidence of a horizontal asymptote?
Yes.
How many?
2.
Absolutely 2. Vertical asymptote, do we have evidence?
Yes.
Yes, we have evidence of a vertical asymptote. Maybe 1, maybe more, not really sure. Do we have evidence of a hole? Think about that question before you say anything. Do you have evidence of a hole?
No.
Why not?
You don't see it on the graph.
Say that one more time.
It's not on the graph.
You will never see the hole. It's the teeniest, tiniest little point that's going to be missing. Right? Sometimes on the graphs, like we create, we do like an open circle or something. Here's what I care about. I care about right now that you guys are all convinced there's some horizontal asymptote over here at y equals something. And there's some horizontal asymptote over here at y equals something. And there's some vertical asymptote over here at x equals something. We're good? Okay, get me started. How are we going to find that vertical asymptote? Good, set the denominator equal to 0. If you know what to do, go for it. Vertical asymptote, e to the negative x minus 1 is equal to 0. I'm going to go fast, because I know I'm in the presence of greatness. We did this on the summer assignment. Natural log, p in front of the log. I just said p in front of 4 campuses of teenagers. Fabulous. Negative x, natural log of e is 1. Natural log of 1 is 0. Negative x equals 0. X equals 0. Is everybody okay? No?
I'm still trying.
Hold on.
What's definitely going to happen in the world of AP Calculus, all the other skills are going to get so strong. Is everybody okay now with x equals 0?
Yes.
Okay, good. Josue, we have a vertical asymptote at x equals 0? This is it? This is your evidence?
No, it's a candidate.
This is a candidate. My friend up front, Claudia, how do you decide hole versus vertical asymptote?
Don't you have to do the limit?
You have to take the limit. So I take the limit as x approaches 0 of 5e to the negative x over e to the negative x minus 1. I want to take that limit. You can use this supply kit. It's all right. You're in training. Take the limit as x approaches 0. How am I going to find that limit? What are you going to do? Trust your instincts, Jessica, Melissa, whoever you are. As long as one of you responds, I'll never know. How are you going to find that limit? Jessica, Melissa? You're going to plug it in. Is it okay to plug in 0?
Yes.
I think so. Now, if I do that, I'm going to get 5e to the 0 over e to the 0 minus 1.
Yeah.
I get 5 over 1 minus 1. Anybody see a problem?
There's a number on top.
Alejandro, what's the problem?
Number over 0.
This is a number divided by 0. And here's where we need to be careful. We're talking about limits.
Yes.
We're talking about as I get what?
Go to 0.
Close to 0. Do I ever actually get to 0?
No.
No, so it's okay. I don't actually get to 0. We're talking about what happens when you get close to 0. So as x gets close to 0, this part gets close to 1. And close to 1 minus 1 is close to 0. 5 divided by close to 0?
0. Undefined. Undefined.
Uh-oh.
Undefined.
5 divided by close to 0 is one of the infinities. Depending on what side you're coming closer to 0, it's either positive or negative infinity. Your conclusion based on what you just saw?
There's a vertical asymptote.
There's a vertical asymptote. Janaea, is it possible that it's a hole at x equals 0? No. Right, it is either a hole or it's a vertical asymptote. Jasmine.
Oh yeah, why didn't we have to have the annoying little brother? Like the whole way?
Why didn't we?
Yeah.
Great question, right? The limit as x approaches 0. Once you get to the plug-in part, you don't have to write it anymore. Okay? Now here's the thing that I'm going to ask you guys to do with your graph. I want you to add that limit notation to the graph here. So we know we have a vertical asymptote where?
0.
At x equals 0. But what I want to see in terms of your limit notation is I want you to describe what's happening here. So I'm going to say the limit as x approaches 0 from left of f of x. What's that equal to? Positive infinity. And over here I'm going to say it's the limit as x approaches 0 from the right of f of x is negative infinity. That's what I want to see on your graph. We're not done. I know you wish we were. We're not done. Abel, why are we not done?
Because we still have to. Oh, so we're not done yet because we still have to try the other side.
What do you mean?
Like since we plugged in 0,
Uh-huh.
then we have to now find the horizontal.
Ah, okay. You said the other side, and what you meant was the other asymptote? Okay. So, Abel, you said go find the horizontal asymptote. Salma, what did he really mean? Okay, he really meant end behavior. So I need to find the limit as x approaches infinity of 5e to the negative x over e to the negative x minus 1. That's what I want to find. Hector, I know the graph is in front of you, but that's a crutch right now. I want you to have a quick strategy conversation with somebody near you. How do you find that limit? What are you going to do? Don't say plug in. I'm sorry.
Can you use your calculator?
Are you
Oh,
okay with it?
I think I'm okay. Don't plug in.
No, use that notation as x.
Oh yeah.
X approaches
Oh yeah. You make it in your brain.
Yeah, you look it on
math.
right.
Or you could plug in.
You can.
Just put it
I mean,
down.
you can.
They're not gonna
Again.
They're calculating.
I am so excited. No one wants to plug in infinity. That is so good, Fabricio. No one wants to
I
plug in
didn't say plug
infinity.
in. I said calculator.
The conversations I heard at most tables was, what are we going to do instead?
Use your brain.
As
Yeah.
x approaches.
As x approaches.
Right, we're going to use that notation. This is the notation that still is not making it onto problem sets for some reason. As x approaches infinity, I want to come over here and say, is there something I know? Do I see any parent functions happening here?
Yes.
I think we do, right? Cassandra, what parent function do you see?
Is it Howie?
E to the negative x. I bet everybody can tell me exactly what happens. As x approaches infinity, e to the negative x is approaching 0. So look what's going to happen. X is approaching infinity. E to the negative x, you guys just told me, is approaching 0. 0. What happens to the whole fraction?
5 divided
5 divided by
Oh,
negative.
5? This should be 0 over negative 1, which is 0. My conclusion is that I have a horizontal asymptote at y, at not negative 1, at y equals 0. Look at the graph. Does that match?
Yes.
That is exactly what you would have expected. So you have a horizontal asymptote at y equals 0 because the limit as x approaches infinity of f of x is 0. Hector.
So then what about the other percentage?
Oh, Hector. God, wonderful. So what about the other one? Let's try that. 5e to the negative x over e to the negative x minus what? I'll tell you right now, we are going beyond calculus AB in this right now. Have a quick conversation with somebody near you. What are you going to do? Don't talk to me.
Use the same
The same thing as before.
Same notation.
So parent function is this.
Somebody's being funny and said plug in.
Fabricio.
I didn't even say it.
Hey, don't point fingers. Don't point fingers. We're on camera.
As x approaches negative infinity, everyone's going to tell me what happens to e to the negative x. Positive infinity. So if I look over here at my fraction, 5 times getting close to infinity. That's infinity, right? This guy over here, infinity minus 1. Infinity, and what do we know about that?
Indeterminate form number 2.
It's indeterminate form number 2. Now what I really care about is that it's an indeterminate form. Now here's the part that I'm going to blow your mind a little bit, and that's okay.
Oh my god.
I want to show you a new trick for evaluating this limit. I do not, repeat, do not want this to be the thing that freaks you out. I'm just showing you another way to evaluate a limit, and we are not going to panic. What I'm going to do is I'm going to multiply by e to the x over e to the x. Have a quick conversation with somebody near you. Tell them why it is okay for me to do that. And it's not just because I have a master's degree.
Because
Like,
of the
don't we use the
Okay, what I heard from 4 different groups while I did a lap, this is legal because it's 1. It's fancy 1. Now, your question for all my high flyers, you're going to be, but why, coach? Why? Because it works.
Yes.
I am not worried about this right now. But let's do it. Brianna's having a moment back there. Let's do it out. 5e to the negative x times e to the x. One of those things you guys did over the summer, in that summer assignment, had to do with like working with like exponent rules and the bases. And when the bases are the same, what do? If you're multiplying, you add the exponents to get 5e to the 0. Do it down here. E to the negative x times e to the x. E to the 0, 1 times e to the x. E to the x. If I find the limit as x approaches negative infinity of 5 over 1 minus e to the x, let x approach negative infinity. Think about it before you say anything. X approaches negative infinity. The graph of e to the x, what's that doing? E to the x looks like this. As x approaches negative infinity? 0. You've got a 0 hiding in there on you now. 5 divided by 1 minus 0?
5.
Is 5. That's not your answer, that's the supporting work. The answer is that you have a horizontal asymptote at y equals 5. And if you look at the graph, doesn't that kind of fit?
Yes.
Right, you may not have guessed exactly horizontal asymptote at y equals 5, but using your limit knowledge, limit as x approaches negative infinity of f of x is equal to 5. Okay? Before we go any further, I want to tell you guys what the problem set is. You guys picked up 2 handouts on the way in. One is the thing that you're taking notes in right now. The second is the problem set. It says something like redefining asymptotes revised at the end. There are 4 graphs at the top. For all 4 graphs, you're going to go through this whole process that we just went through. Horizontal asymptote, vertical asymptote, removable discontinuities if they exist. I also want to see your graph with all the stuff. So what? So you get to use your calculator, but you must show me all the limit stuff. I want the limit stuff to support what you're seeing on the graph. You're going to do those 4. None of them are harder than the one that we just did. And then there's 5 AP questions that I'm going to ask you guys to do, and it's due Wednesday. Please put a note at the top that it's due Wednesday. Cassandra, you had a question for me.
The whole thing, even this.
The whole thing.
I thought you said that if you get a number, it's a whole.
If when you're taking the limit as x approaches your candidate, not when you're approaching the infinities. When you're approaching the infinities, if you get a number, that's your horizontal asymptote. Okay? Everybody good? Tight? Tight like my pants?
So it's only this top.
Those 4 plus the 5 down here.
Oh, okay.
Okay. So here's what we're going to do. I've got 1, 2, 3, 4, 5, 6. Yeah, we'll call it 6 groups. We're going to do an exploration in the next 10 minutes. You are going to become the teacher of a peer in the room. Now, hold on. Hold on. Hold on. Okay, what I'm going to do, if you flip over to page 2, there are 6 different functions. For the function I'm going to give you, Josue, you can join whatever group you're going to need, because I don't think we're going to get to do all the calculator stuff I want to today. Okay? You're going to find for that function horizontal asymptote, vertical asymptote, removable discontinuity. You have 4 minutes to work with your team on that one problem. I want all the limit notation. I want it all. And then I'll check in with all 6 groups, and then I'm going to switch you up and you're going to teach someone else how to do that problem that you just did. Every single one of you has to walk out of this first 4 minutes ready to teach someone else. Okay? Okay, so Team Jessica, exploration 1, function number 1. Team Josue, exploration 1, function number 2. Team Jaylene, exploration 1, function 3. Team Juan, exploration 2, function 1. Team Fabricio, exploration 2, function 2. Team Magoo, exploration 2, function number 3. You have 4 minutes. You're only working on that one function.
Okay.
So we could also first use the calculator to plug it in, right?
Yeah, you just give us an idea how the graph looks.
It's another one of those tricks that you never would have guessed on your own. But it works because it changes. Right, this is 1. I'm just multiplying by 1, but I'm multiplying by a really fancy so that I can take something that's really indeterminate form, and now it's no longer indeterminate. Don't expect that I'm going to ask you guys to do this. I care less about this part.
It has that horizontal.
You guys got this, everybody? The same thing?
Wait, does it have a horizontal and a vertical?
Over here because this
It
wasn't.
has a horizontal. It has a vertical. Ahí está.
It doesn't?
Yes, it has a vertical.
You go to infinity.
It has a vertical as opposed. También tiene un horizontal.
It goes, no, it goes.
Oh, yeah, que son end behaviors, ¿verdad?
Yeah.
Tú ya nomás tiene horizontal.
Okay, I just wanted to like
It's up
open your
allá.
brain and be like, oh, something else is possible. Done.
So en la caja para vertical ponemos nada. I mean,
Thank you for looking out for the Spanish-speaking folks. Is this Telemundo?
all right, let's go back on track. Let's get back on track. So on vertical asymptote we put nothing, right?
Are you okay?
Right? Yes, sir.
And somebody didn't get their assignment back because they didn't put their name on it.
Okay.
No, mine is over. You're saying so.
Oh,
I'm finding the vertical, but I'm finding the vertical.
Pero hacemos vertical.
Uh-huh.
That's where I went in el mundo.
Okay, so we just do the length.
Horizontal.
as
We're just gonna do all
goes
this.
into infinity,
Yeah.
right?
Yeah. So we're gonna put that.
And then
Hold on.
8 to -1. I mean 1 to. So we do the notation as x approaches infinity. 8 divided by 1 to the u of x.
Oh wait, no.
Oh wait. Oh
No, you messed up. It's just e to the x.
I know.
Yeah, as x approaches infinity, comma, e to the x approaches.
that's how it works.
Para allá un poco.
e to the x approaches.
Gracias. Un poquito más. No, no se vale.
English.
No Telemundo.
Okay.
Okay, so I got S.
No sale. Nomás es chiquita la pantalla.
Okay, as x approaches infinity, comma, y después nomás es e to the x, ¿verdad?
Okay. E to infinity is 1.
So
No,
e to
infinity.
No,
So 1 minus infinity is infinity, and then 8 over infinity is
0. Undefined? No son it's undefined. It's 1.
1.
8 divided by infinity
No,
is
mira,
1.
if it goes approaches infinity.
From the back is 1.
Okay, but we're doing the notation.
To you? Nomás salen ellos dos.
We did Telemundo, guys.
So then this only show you this part and one.
Okay, how many would like 2 more minutes?
Over here, baby.
2 more minutes.
Okay, pero mira lo que está haciendo
You
Fabricio.
must be at the point where you can teach someone else. Everyone is going to teach someone else.
Luego Fabricio is doing as x approaches infinity, comma, but he did the e to the x. He broke it down. Remember the uninvented? Remember? I don't know. Fabricio, why are you putting the whole thing? You're confusing me.
No, mira, okay, look.
I do it the whole thing.
Yeah, so it'll be 8 over 1 over 0. It'll be 8. So that's. Oh, it can be 8.
No. It's 1.
No, it can be 1. Okay, but.
I'm touching 1.
I know. But if we do the notation, e to the x.
Hey, there's 2 though. Look.
Yeah, there's. There's 2. We're just doing one of them.
There's 2?
Yeah.
So use them out?
Zoom out, yeah.
I told you, Fabricio.
Oh.
Hey, ¿cuál era el que usaba Mr.
Oh,
just to hace solo?
let's see.
No idea who I'm talking about.
The one that.
Mira, te voy a enseñar. You go to menu, you press 4, then you press 4 again, you press it on the center, voila. Then you press this one, voila.
Wait, what?
¿Ves? Sí, es 8. ¿Ves? Es 8.
No, yeah, you already did it. You already did it. He didn't have to zoom out. How you zoom out it?
Zoom out the menu. Number 4. Number 4.
That's what I show him.
Oh.
And then so we get as x. Look, this is what I got. Is this what you got?
No.
It's 1 and 5.
I got 8 over 1.
It's not 8. It's 5.
Why 5?
You can see it in the
All right, when I say calculus, you say ready, calculus.
Ready.
Calculus.
Ready.
Okay. Shh. And you go quiet. Okay, I'm going to tell you what the answers are for your function so that you're not teaching someone badly. Exploration 1, function 1, horizontal asymptote y equals 2, vertical asymptote x equals 2, removable discontinuity or a hole at x equals 0. How did that go? Okay, function number 2 for exploration 1, horizontal asymptote y equals 0, vertical asymptote x equals 2, hole at x equals 0. Function number 3, you have no horizontal asymptote. You have a vertical asymptote at x equals 2 and a hole at x equals 0. Exploration 2, function number 1. How many horizontal asymptotes? Uh-oh.
No.
There should be 2. You should have a horizontal asymptote at y equals 0 and a horizontal asymptote at y equals -8. You should have a vertical asymptote at x equals 0. And you have no removable discontinuities. For you guys were function number 2?
Yes.
What about horizontal asymptotes?
2.
2. What are they?
8.
1 and 5.
Not 1 and 5, no.
0.
It should be y equals 0. Horizontal asymptotes, I want the equation of a line. Y equals 0 and y equals 8. A vertical asymptote at x equals 0 and no hole. friends over here, 2 horizontal asymptotes. Y equals 0 and y equals 8. No vertical asymptote. No removable discontinuity. Okay, here's what I need you to do. Every one of you, if you did exploration 1, needs to find somebody who just did exploration 2. You have 4 minutes. Take turns. Exploration 1, teach to exploration 2. Then exploration 2, teach to exploration 1. You're not giving answers. You're taking them through your process. Make it happen. When you get to that point,
I want exploration
But did you do exploration 1?
Number 2. Okay, Jose. She has a new game. I mean, a new team. Why are you here? I'm playing.
your person, because that means there's somebody out there right now that doesn't have one. Okay, you need to go over here.
Oh.
Okay?
So the camera's pointing at me?
Yes. It's not pointed at anyone. It's pointed forward.
It's at both of you now.
Me?
3 minutes left. Make the most of this opportunity.
So, guys, how you say this? I got function number 2.
Okay.
And the first thing I did is divide everything by x squared.
Wait, what? Bruh.
I divide everything by x squared.
Hold up, wait a minute. Did you find the limit or something?
I divided by x squared. I found that more simple. I got the same thing. It's called saving time. Live better. Yes,
You know what? Pull it back for it.
And once you divide everything, the only ones that cancel out will be 5. So it will be literally 10x divided by x squared divided by 5 minus 10x divided by x squared. Then you plug in infinity because the limit.
It's gonna be 0.
0 and everything. Yeah. So it's gonna be 0 divided by 5, basically. Which will give you y equals 0. That's the
Horizontal.
exactly. And then for the other one, for the vertical asymptote, I simplify the denominator, or 5x parentheses x minus 2 parentheses. Then I set it equal to 0.
Stop looking at me like that.
5x equals to 0 equals x to 0.
You said 5x times.
Equals to 0. Equals x equals 0. Because I simplified.
Oh, because you factored and then you're setting each part equal to 0? Sorry.
And then I set x minus 2 equal that to 0. And I'll give you my candidates will be x equals 0 and x equals 2. After doing the limit, or plug it in, I got 0, 0. X equals 0, which means there's a hole. Because when you plug in zeros,
You mean a car?
yeah, you plug in.
Wait.
It's not for weight.
Bear with me.
But if you want to leave it on my desk, actually put it in my brown bag, yellow folder.
So when you plug in 0 divided by 0, which is 102. That's a hole.
But that's it.
When you plug in 2, your grass is going on. I'll give you.
All right, closing out on conversations in 5, 4. Get everybody to head on back to wherever you were before. In 3. Cynthia's moving the camera in 2. Good-looking people all around me. Okay, so next problem set. When's it due? Wednesday. The first 4 problems are just like what you just did. I will tell you right now, though, from going around the room, I'm not happy. I mean, I'm not angry. Okay, but I would not describe myself as being satisfied with the notation that I am seeing right now. I really want you to look at that model problem that we started class with and use that as your guide. If we're looking for horizontal asymptotes, you have to be writing limit as x approaches infinity of blah, limit as x approaches negative infinity of blah. I know it feels really picky. I am holding you to the same standard that you're going to be held to this summer or in May when you take the AP exam, and also you're going to grow in this process. It's good. So sadly, we only have 6 minutes left, so we're going to do this awkward transition. Right, my daughter started 6th grade today. I get to see 1,000 middle school students. I know about awkward transition. So I want you to do your awkward transition face. Whatever that happened to look like, you're like, Alejandro, great job. Okay? Okay, awkward transition to a new topic that we're going to continue with tomorrow. The topic is called relative growth rates. Oftentimes, as mathematicians, we are interested in comparing 2 different functions to see which one grows faster. I'm not going to tell you anything else. What I did is I took out one of my college calculus textbooks. I've got a whole bunch to pick from. And I typed up everything that was there on the page. Next year when you're in college, you are going to be expected to read from textbooks on a pretty regular basis. So I'm going to stop talking, and you have 4 minutes to read through all the text that is on here. There's some definitions at the top, there's a worked out model problem at the bottom, and then a conclusion that you need to draw on the bottom. You have 4 minutes, it's going to be silent reading. Mark this up. If you have questions, put a little question mark. Be ready to discuss in 4 minutes.
Can we separate the potato from the center?
Yeah. Yeah, if you want to take your cradle off, I'll pick them up. And we're reading.
Merci. Going to talk about the things you're reading right now, I promise.
Okey-dokey. So, when we talk about relative growth rates, we're talking about comparing two different functions and seeing which one grows faster. That's all that we're talking about. That's all we're talking about. So if I were to say, hey, let's take the limit as x approaches infinity of f of x divided by g of x, and my answer is 0. Which one's growing faster?
None, because it's 0.
Which one's growing faster if the limit is 0?
G of S.
None, because it's 0. So
If
They're equal.
they're equal. Go back to what you just read. At the very top of the page, they've defined. They may have used different function names that I did, and that's okay. Which one's growing faster?
They're equal. They're equal.
They're not equal. There's 3 cases. You could get 0 for an answer, you could get infinity for an answer, or you could get a number that's not 0 for an answer. If you're getting 0 as your final limit, the one that's growing faster, it's the denominator. This guy here grows faster. If I take the limit as x approaches infinity of f of x over g of x, and I get infinity. Which one grows faster? It should be f of x grows faster. And if I take the limit as x approaches infinity of f of x over g of x, and I get something like 5. Not 0, not infinity, 5. Your conclusion? They grow at the same rate.
Is that the slope then?
Nope, we're not. Good question. No, and we'll talk about that more tomorrow. They grow at the same rate. Janae, hold on just a second. So look at this example, 100x squared plus x divided by x cubed plus 1. And the question is, which one's growing faster? So what they did is they said, let me take the limit of f of x over g of x, so 100x squared plus x over x cubed plus 1. As x approaches infinity, the numerator, approaches infinity, the denominator approaches infinity. Is that 0?
No.
Infinity? Some number? Indeterminate form. So we went through and we did the work. We said, so let's take that limit, and I multiplied by 1 over x cubed over 1 over x cubed. And you guys all know that this is legal.
Yes.
Because?
Fancy 1.
Fancy 1. The x cubed was picked because x cubed is the largest degree. I distributed the 1 over x cubed through. I simplified, and I get 0 as an answer. The conclusion that you write at the bottom. Which one grows faster?
G of x.
G of x grows faster?
Yes.
Okay, so G of x grows faster than f of x. Quick show of hands before we leave. How many of you all were pretty sure that's what was going to happen when you first looked at the problem? Look at that one more time. Look at those functions one more time. How could you quickly determine which one's growing faster? Alejandro?
Is it the x cubed?
Maybe it has to do with the x cubed. That's the conversation for tomorrow. This has nothing to do with the homework you're doing tonight. Not at all. Not even a little bit. Okay? We're going to turn that off. You can leave it on my desk. Cynthia, thank you so much.